To solve these equations, it requires a little bit more thinking. So for A, if you had 3 times some number and then you added 7 to it, you would get 13. So what would 3 times that number have been? Well, if you had to add 7 to make it 13, then if we take away the plus 7 from both sides, then the 3x on its own would have just been 13 minus 7, which is 4. Because the 4 plus the 7 makes the 13, so this bit here must have just been 4. And then we can divide both sides by the 3 to get 4/3. We don't need to write that as 1.3 recurring, I'll just leave it as a fraction. For B, if you imagine now that we take that minus 8, and I'm moving it to this side by making it plus 8, then that leaves 5x equal to 13 plus 8. It's always important when you box these things to remember the sign in front. So the 13 plus 8 is 21, and then x on its own is 21 divided by 5. Again, I'm going to leave it as a fraction. For C, if I have my negative 2 here and I move it to the other side, it's going to be a plus 2. So x over 5 is equal to 3 plus 2, which is 5. And how do I move this divided by 5 to the other side? I would apply its inverse, and the inverse is times by 5, so 5 times 5 is equal to 25. And finally D, if I had 4 lots of something in a basket to get 8, what would one of those baskets have been? 8 divided by 4, which is 2. And then if I had a number and then I took away 3, and that gave me 2, then the number on its own must have just been 5. Okay, in the next series of examples, the thing that's different is the fact that I've got x here and x over here. So the first thing I need to think about is to move the x terms all to one side. And that means if I have 4x here and 3x on this side, if I take away 3x from both sides, that leaves x on this side. So I'm taking away 3x from here, and I'm taking away 3x from here. And the plus 6 and the plus 10, I want to get rid of the numbers from this side because I want just an x there. So I want to take away a 6 from here, and I want to take away a 6 from here. So that means a 10 minus 6 is 4. X equals 4. On this side, I want now to move my x's because I've got a negative x on this side. I want to move it. I want to make it a positive x by moving it over there. So that means that I've got to take my number and move that to this side. And that would be 6 minus 8 would be minus 2 on this side. And I should do that in red really, shouldn't I? Because that's the number part. So on this side, 6 minus 8 is minus 2. And on that side was negative 2x. I've added 2x now to give me 2x on this side. And next I need to divide both sides by 2. So x equals negative 1. And this isn't a very good way of writing it. I should write x as the subject like that. Okay, finally, if I wanted to move my x's all to one side, I'm going to choose to move my negative 6x to this side by adding 6x. So then I'm left on the left-hand side with 10x. And on the right-hand side, I'm going to move the numbers. So this negative 2 moves to this side by adding 2 to 8, which is 10. And then x will just be 1. Okay. Final example. Use the information in the diagram to write down an equation, so that's part 1, and then find the value of x. So I have to try to find an equation for all of this. Assuming that this is in a flat space, it's not on the surface of a balloon or anything, then all of these angles are going to add up to 360 degrees. That's what I know, that's the fact that I know about this. So all of these add up to this. So my equation has to have an equals in it. So that means that my 170 plus the x minus 10, which I'm going to write in a bracket, and then plus, and again in a bracket, 2x plus 50. Adding all of them together gives me 360. So that's my equation. And then it says, and then find the value of x. That means just manipulating this, so expanding all the brackets out. So because there's nothing really that interesting in front of the brackets, I could have just written this without the brackets in anyway. I could have just written 170 plus x minus 10 plus 2x plus 50 is 360. When I expand this bracket out, nothing actually changes here. So that's why I've just written the same thing again without the brackets. If it was a negative in front here, then it would, and that's why I wrote them. And by putting all these together, I get my equation, 210 plus 3x would equal 360. And it's good practice actually to get the equals all in a straight line. So this I really should have written a little bit further across. And then I'd take away the 210 from both sides, which leaves me with 3x equals 150, and then x is equal to 50. Okay, have a go at the exercises.